Hello, I am Emre Yavuz, and this is the data analysis workshop with COVID-19, and it will focus on the visualization of data using Python and to extent what this data shows us. Before I get started, I want everyone to know that if you have questions, you can put them in chat, or if you want me to slow down, you can tell me in chat. I'll try to read it. Okay. So again, before we start, I'm going to explain how you can obtain COVID data or data in general. The data is collected by various research organizations for data analysis. And I recommend that you always question the reliability of the data source to avoid garbage in, garbage out. Our data comes from the Johns Hopkins University Center for System Science and Engineering, and they have a GitHub repository that provides daily updated data that we use in this workshop. Okay. So in chat, I'm going to paste two links to everyone. The first one is a link to cocalc.com. That is where we will be programming. And then the next one is a bit.ly link where you can get this covid.zip file. So what you want to do is download that, and then at cocalc.com, go up here to upload it and find where you downloaded your file. And then, yeah, I'm gonna wait until, I don't know, maybe like 2 minutes for everyone to get this done. If you're done, put done in chat or thumbs up so I know when to move on. I'll paste it in chat again. It's this bit.ly link. And then the upload is up here. Okay. Yeah, so when you open up the link, there might be a pop-up that says welcome to CoCalc. You can close that and go to the files, and you can upload from there. So to upload the file, you go up here to upload. And if you click it, you can find where you downloaded the file and then upload it.
Are we uploading the entire zip file or every single little file? I'm trying to
upload the entire zip file. Mm-hmm. The upload button is in this files part, and it's at the top right here. Okay, I think I'm gonna move on in another minute. So if you have questions, continue asking them. You don't need to know how many files there are right now. We will unzip them later. So upload the entire zip file. You don't need to unzip yet. Yeah. Okay. I'm gonna give another 10 seconds and then I'm gonna move on. I'll put the links to the website and to the download one more time. Okay. So now we are going to unzip the file. So to do this, we go in the terminal command and do unzip our file covid.zip. And if we run it, we should see all these files. So I'm going to give you some time to do that. Unzip covid.zip up in this terminal command up here. And the terminal is right above where you uploaded your file from. We aren't hacking anything. The site will just help us type code without having to download Python or anything. It's just covid.zip. You don't need to type .zip twice. So just type unzip covid.zip. You should be able to use that if you want. So after you unzip correctly, you should see all these files pop up. So before it was just covid.zip, and then you should see all these here. Yeah, just do unzip covid.zip after you've uploaded the file. I think I'm gonna continue in another minute because it seems like some of you are still having a bit of trouble unzipping it. But for those of you who have finished, you should open this hello world.ipynb. And this is where we're gonna be typing all of our code. And then this data analysis.ipynb. And this will have all the code that we will be doing today. But we're gonna mainly be in this hello world file. Okay, I think I'm gonna continue. So this is the CoCalc website, and on it, it allows us to use Jupyter notebooks. And this allows us to type code in cells. So here, this is a cell that has print hello world in it. And then to run a cell, you do Shift Enter, and that's how it works. Also here, some other information. At the top right of each cell, you can see the number. And when you do Shift Enter, it will automatically open a cell below it.
Wait, I have a question. I don't see the hello world like on the when I unzipped it. I don't see it.
There should be a hello world.ipynb file when you unzip it.
COVID cases, state, cases, country, time series, COVID-19 deaths, global, time series, COVID-19 confirmed, global.
That's all the CSV data that we're going to be using. There should be a data analysis.ipynb and a hello world.ipynb file that was unzipped with the covid.zip. So I don't know. Okay. I think I'm gonna start. So we're gonna be using this, start by using the pandas library, and it can read CSV data into a data frame that you can work on in Python. And to import it, we do import pandas as PD. And then to read the CSV data, we have to create a new data frame, and we call it DF, stands for data frame. Country equals PD dot read CSV. And then do cases country dot CSV. And that is one of the CSV files that was in the COVID.zip. We aren't importing the CSV because pandas is making a data frame from it. Okay. So if we do Shift Enter, it'll run, but we don't get to see the table. So to show it, we give the name that we called the data frame, so df country, and then we do dot head, and this by default, okay, I spelled country wrong. Okay, so it should give the top 5 in the file. But if you put in a number in here, for instance 10, it'll show the top 10. Is this easier to read? All right.
I have a question.
Yes.
So is it like it only shows 0 to 29? Is it because like 0 isn't like it doesn't start with 1? But why doesn't it do that? Why doesn't it start with 1? Why does it start with 0?
That's just how it works. I'll just say that. It works like an array. Okay. So now we have this, and sure, we can see the table, but it's not really organized. You run it with Shift Enter. So if you do Shift and then Enter, it'll run. There. So this isn't really telling us much. It's just showing the top 10. But we can sort this. So if we do, so to sort it, I'm going to sort by deaths. So if we do, I'm going to make a new data frame of the sorted values. I'm going to call it df deaths, death sorted. And that is equal to df country dot sort values. And then this sort values method, we have to put what column we're sorting by. So it has, so make sure when you're typing it, it has to be exactly what is in here. Otherwise you might get errors. So def, and then if we do ascending equals false, it'll make sure it's from greatest to least. And then if we do df dot df def sorted dot head, we can see that it's sorted by death. So the most amount of deaths is the US, unfortunately. Okay, so I'm gonna wait for people to catch up. Thumbs up or done if you are done in chat. If it's not working, my best suggestion is that you need to try to make sure that everything is exactly as I type it, because Python is case sensitive, and spelling matters. So yeah. Okay. Now we can also stylize it, and we can do that by doing dot style, and then we can give it a gradient dot background gradient. And then in it, we do CMap. And you can do, you can give it a string reds. So pandas, depending on what you put in here, will colorize it differently, but it has to be specifically reds. I think blues is a thing too. So make sure you do that. Also, we have to specify which columns we are colorizing. So if we do subset equals, I'm going to show deaths. And then I'm also going to do confirmed. So now we gave a gradient to the confirmed in deaths column.
I have another question. How do we get rid of all those zeros at the end, because they're basically doing like nothing there?
Yeah. I was just gonna get into that. So to do that, we can set the precision. And so doing dot set precision, we can give a value. So if you want 1 0 to be there, you can do that, and it'll make things a lot cleaner. Yeah, you can download the CSV files to the computer. It's just in the COVID.zip file, and you can just extract it, which is similar to how we unzipped it earlier. Okay, so if you could type done in chat if you're ready to move on, or thumbs up. Okay. It looks like most people are ready to move on, so let's do that. This next part takes a long time, and I don't know if we have enough time to do it. So I'm going to quickly show it in this data analysis.ipynb file I told you to open up earlier. So here it has everything that we're going over. And if you go to the 5th cell and go up here and run all above, you will be able to see this. And here, basically, I would show how to create this deaths per 1 billion population column, like to just make it. So you're gonna wanna go into this data analysis.ipynb and then go to the 5th cell. And up here, there's the cell drop-down menu and do run all above. Yeah, so I explained earlier that this, where you type your code, it's called a cell. Anyways, you don't have to type this right now. So basically what you do is import a different CSV file. And this one is for population. That's how we create this. And first, before making it, you need to merge the two. And you do this dot merge. And then
I need to ask a question and I'm not getting an answer. You keep saying go up here. And if we're not watching your mouse, we don't know where go up here is. So will you please actually tell us, go to the file drop down, go to the time travel, go to the save. Where was I supposed to find go up here? There is no go up here. What do you mean, please? Thank you very much. I appreciate it.
Okay. By that, I meant to go to the cell after you have went down to the 5th cell here. And at the top left, there's the cell option underneath time travel. And you do run all above. You don't have to do this because you don't need to type this for the sake of time. However, I'm trying to explain how you would have done this. So here, yeah.
So I just have a really quick question, and then also, yeah, thanks. Your instructions are really good, and then I managed to follow along. So yeah, so this speed is good. Actually, a bit faster would also be good as well. And then also, I just have a question. How did you
Okay.
data into the table? Because did you make the data yourself? Did you download it from like Hopkins and all that stuff, or how did you get the data into that format?
I didn't.
How did you get?
Can you say that again?
All the data was
How
already
did you
in
get the
CSV.
data into that format?
This format here.
I mean,
This.
for example, the starting data, like the COVID.zip file. Did you download it yourself, or how did you do it?
It's open source, which means everyone can download it for free, and it's already in that format, as it's very easy to use.
Okay. Yeah. I think I'm gonna skip this part because there's a lot to go over. However, if you want to look at this yourself after this ends, you can. I gave you this file, this data analysis.ipynb, and I added comments which explain what each line does. Okay, so let's go back to the hello world.ipynb file, which is up here. And then we're now going to create a scatter plot. So to do this, let's start by importing a new library called Plotly. And we're going to do import plotly.express as px. And then to make the plot, we need to create a new figure, and I'm going to call it fig equals px.scatter. And then we are going to use this data frame up here to do it. So we're going to put in df def sorted .iloc, and this iloc function basically allows us to choose to select different parts of this data frame that we created. So we are going to select the range 0, 10. And then for the scatter plot, we need to set an x-axis and a y-axis using this. So I'm going to do x equals this country region. So country region. And then do y equals deaths. And then I'm also going to set the size of the bubbles in the scatter plot to be proportional to the deaths. But since the deaths are quite high, I'm going to set a max size. So size max equals 60. And then also I'm going to make the color unique to the country region. So if you do this, you will create a new figure. But to show the figure, you can do fig.show, and then ta-da. So if you wanted to, in your free time, you can set the X to whatever you want up here, any column you want, and Y to any column you want, and it creates these scatter plots. I'm gonna put this code in the chat in case anyone needs to catch up, and type done if you need if you want to continue. To comment in Python, you do this hashtag and then type whatever you want. Okay, cool, I'm gonna continue. Now, what we're gonna do is we're gonna be comparing the confirmed cases over time. And to do this, we're going to be using another CSV file. And this time, we're gonna create, like last time, we're gonna create a new data frame. So df confirmed. And since we're trying to compare the confirmed cases over time with each country, we need to use a different CSV file. And this one, when we do pd.read CSV, it's called time series COVID-19 confirmed global.csv. I'm gonna put that in the chat because it's very long. Okay. And then I'm also going to set an index column. So index call equals country region. And that is part of this data. Now, if we do df confirmed dot head, we see all the confirms, the amount of confirmed cases in total updated daily. Now, like with the last one, we are going to sort it by the most recent date. And to do that, we do dot sort values. And then if we do df confirmed dot columns -1, this -1 allows us to select the title of the very last column. So it can sort by that. And then if we do, like last time, ascending equals false, it now sorted by that, or it should have. Okay, I'm gonna give a minute. If you have questions, put them in chat, and then type done if you're ready to continue. Okay. Okay. I'm actually going to make a new data frame of the sorted values. So df confirm sorted. And then if we do df confirmed sorted dot head, I think it should show us the sorted one. Okay. I had an error recently that was similar to yours. So try doing this. Try going up to the cell, which is underneath your open files and time travel, and then do run all. That might fix it. Okay, I'm gonna continue.
Can you just go back up for a moment?
Okay, yeah.
Okay, you can move on now.
Okay. So now we're going to graph this data. And to do this, we can do df confirmed sorted dot iloc, and we are selecting what we are using, and then 0, and then doing this 30 colon will make it so the 30th, it will choose the 30th column and everything after that, because most of the data begins at day 30 or around day 30, because before then it was still young. Okay. Now after this, we do dot plot legend equals true, and then I'm going to turn the grid on. And then if we run this, we get a plot of the US's confirmed cases over time. But how do we compare all the countries? Well, we can make a for loop. So if we do in the same cell for I in range 0, 8, so this will be the first 8 rows. It'll run this and change this 0 in here to I, and now we should see all of this. Now, as you're typing, I'm going to explain this a bit. Comparing exponential functions can be distorted. So what I'm going to do here now is make log y true. So this will set the scale for the y-axis to be logarithmic. So now the slope of the plot is the infection rate. So we can see for most countries, the infection rate is flattening. However, it does seem to be rising again for France, Argentina, and Colombia too. Okay. Done. If you guys are done. Okay, cool.
Wait, I have a question. So it
Yeah.
says df confirmed sorted is not defined, and I don't see why, because I think I spelled everything correctly. I don't think there's any syntax errors.
Okay, so make sure that you defined df confirmed sorted up here as df confirmed after you sorted it. I don't know. You did that? Sometimes this gives errors if you're on the website too long. So if you go up here and do cell run all, it's up here. It might fix it.
Can you scroll up? Let me take a look at the defining thing. Like, yeah, there. Oh. Well, I did it correctly, but it still says there's an error because it's not defined.
Okay. Yeah. So try doing what I said. Do underneath time travel, cell run all. Because sometimes if you're in the website too long, it gives errors for no reason. Okay.
Now it gave me 2 errors.
Huh. Okay, if you want, if it keeps giving errors, you can go and follow along in this data analysis.ipynb file if it continues giving errors. I am gonna move on. So, yeah, so now we're going to analyze the exponential fit for early United States COVID data. So to do this, we're going to be using more libraries, and we're going to import NumPy as NP. Make sure you do as NP. And then import matplotlib.pyplot as PLT. And then finally do from scipy dot optimize import curve fit. Okay. So now we are going to create the exponential fit for US COVID data in the early 30 days to see what this can show us. So to do this, we need to split the X and Y values into separate lists. And we do this by doing Y. I'm going to set the Y values to Y equals list df confirmed sorted. And then I'm going to do .iloc zero. So this will give the early first 30 days. And then if we do X equals range len Y, this will give us all the X values that correspond to the Y. And then if we do plt dot plot these X and Y values, it will give us this graph of the early US COVID data. Now to make the exponential fit, we will use this curve fit that we imported. And that will give us two values, two lists, M and K. M holds the A and B curve fit, and K holds the standard deviation information. And then if we do curve fit lambda t a and b, and do a times np dot exp b times t, it'll check for the exponential fit for this. And then it's going to check using x and y that we set here. So now, of these, we're only going to be using m because we don't need k. And m holds two values, this a and b that it found for the exponential fit. So I'm going to set a, make a new variable a equals m0, the first one, and b m1. Then if we do y, x, this is going to be the exponential fit of this, a times np dot exp b times x, and it's going to use the same x values and set the a and b that we just found. And if we do plt dot plot x y exp, and then we do shift enter, it should give both lines. So this blue is the original, the actual data, and this yellow line is the curve fit data that we just found. Now, all this shows us is that, sure, it's an exponential graph, but what if we showed the same exponential growth as it continued beyond these 30 days? So we're going to change, to do this, we're going to change our x, and it's going to be the range of 40, or if you want to, 50. I think I'm going to do 50. And do y equals list. We're going to set a new y for the actual using this. df confirmed sorted dot iloc. Zero, so it's the US, and then 40, 90. And then if we do plt dot plot x and y, shift enter, we see the new US data, or the extension of it. Now, one more part, we do y exp, we're going to update it so it uses the new x range. So if you basically copy and paste this, and then do plt dot plot x y x, it shows us this. This is the actual, and this is the curve fit from the early 30 days. So what we find is that around day 25, shelter-in-place decisions were made. And as you can see, it significantly slowed down the exponential growth of confirmed cases. Okay. I think that's all we have time for. Yeah?
Can you like scroll up and just wait for a moment? Yeah, that.
Yeah, okay. So
I also have a question. Yeah, so I just wondering about the data part. How did you do the data exactly? For example, did you get like raw data from the internet, or did they organize the raw data in this form so you could easily do graphs from it?
Yeah, so I got the data from the internet as CSV files. I showed earlier. I'm gonna go back to my slides for a second. That I got it from the JHU GitHub repository. So.
Oh, so how do you find files that suit Python searching? Because if I just search COVID-19 data, then I probably will get like a Google chart, but that doesn't help me at all.
So those, you can download those as a CSV file, and that is what we use for this.
Yeah. Oh, okay. So just for the files you find, download them as CSV if possible.
Yeah.
Okay.
Okay. If you have any more questions about how to do what I did here, or if you couldn't follow along, you can look in this data analysis.ipynb file. It has a bunch of comments for how what each line is doing. And then, yeah. Thanks for coming.